Good afternoon, everyone. Let us start this session. So during the last lecture, we were discussing about the dynamics. So dynamics, it is the branch of mechanics which deals with the study of the objects which are in the motion. So basically it is a motion analysis. So dynamics is concerned with the moving objects. So motion of object or particle is analyzed to get the information about the velocity, acceleration, and the displacement at different time instances. Okay. So the dynamic is divided into two parts. First is the kinetics and second is the kinematics. So kinematics, it deals with the motion analysis of the objects or particle without considering the forces which causes the motion. So in the kinematics, calculations are based on the motion parameters such as velocity, acceleration, displacement, and the time. Kinematics does not involve any force calculation. Okay, so kinematics is the motion analysis without considering the forces. So for example, if a car is moving with the velocity 60 km/h from point A to B, and it takes 10 hours to reach the point B. Okay. So how far is the point B from the A? So this distance between point A and B, we can calculate depending on the information of velocity and the time. Okay. So this is the car. Initially it is at point A. It is moving with the constant speed 60 km/h. Okay, and with this speed, it reaches the point B. So we have to find out this distance. So the data which is available, it is the velocity. So velocity is given 60 km/h. It is equal to distance upon time. Okay, so time taken to cover the distance AB, it is 10 hours. So distance is equal to velocity into time, that is equal to 600 km. Okay. So this type of analysis, that is a motion analysis, it is called as a kinematics part. Now the second part in the dynamics, it is the kinetics. So kinetic, it deals with the motion analysis by considering the forces which causes that motion. So in the kinetic, we will use Newton's second law, then work energy principle, impulse momentum equation. Okay. So calculations involves velocity, acceleration, displacement, time. So we will calculate these parameters, and along with these parameters, we will deal with the force calculation. Okay. So example, suppose an object of mass 5 kg is sliding down the slope, that is along the inclined plane. What acceleration does object get due to its own weight? Okay. So under this self weight, the object is sliding down the plane along the inclined plane. Okay. An object having the mass 5 kg. So we have to determine what is the acceleration. So this is one simple example in the kinetics where one object is moving in a horizontal plane on a flat surface. Okay. So object is having the mass m and it is subjected to external force of 20 Newton. Okay. So what is kinetic analysis? So if you apply the 20 Newton force, and if the object enters into the motion, okay, then what is the acceleration of that object? So this acceleration we can find out by using the Newton's second law. So this part is called as kinetic part. Okay. So this is the object motion under the action of 20 Newton. So object is having some acceleration when we apply the force. So formula for Newton's second law is F is equal to mass into acceleration. Okay. So with this formula, we can find out the acceleration value. It will become force divided by the mass. So force is 20 divided by mass of the object. So this is the example on the inclined surface. So due to self weight of this object will slide down the plane and it will get some acceleration. Okay. So this is the sliding motion. So when you solve the problems of the kinetics, we have to draw the free body diagram. Okay, because it involves the force calculation, and for the force calculation, we must have the free body diagram for the object. So this is the self weight acting in the downward direction. So this is the vertically downward. So as the object motion is down the plane, so we have to resolve this force in the direction of the motion. Okay. So this is the y component, which is the perpendicular to the plane, and the x component is along the plane or parallel to the plane. So it is w sine theta, where theta is the angle of inclination of this plane. So this w sine theta, it will provide the necessary force to cause the acceleration. Okay. So because of w sine theta, object will get some acceleration. So this is the final motion. So equation for Newton's second law is F is equal to mass into acceleration. So F is the external force, and which is equal to W into sine theta, that is equal to mass into acceleration. So for example, is W is 5 kg. So 5 into 9.81 is the W force. Then angle of inclination is theta, that is 60 degree. Mass is 5 kg. So we will get the acceleration value as 8.49 meter per second square. Okay. So as the answer is positive for acceleration, so object, its velocity will increase as the object slide down the plane. So positive acceleration shows that increase in the velocity, and negative acceleration shows that there is a decrease in the velocity. Okay. So this is the difference between kinetics and the kinematics part. Now, what are the applications of the dynamics? So this is one application in the military. So first application is, if you want to choose a proper projection angle for the tank, then we can decide with the help of the projectile motion calculation. And second, to determine the proper distance from the target to drop the bomb from the fighter plane. Okay, so these are some military applications for the dynamics. So this is the first application. So suppose we want to fire the shell from the tank, and if you want to hit the target, which is at distance r, that is shown in the figure, then to hit the target, we must decide the proper angle for this gun. Okay. So if you select the proper angle as per the distance of this target, then we can hit the target. So this is the projectile motion for the shell. Okay. So this is the part of the projectile motion in the kinematics. Second application is, suppose we want to hit the target by dropping the bomb from the fighter plane. Okay. Then we have to select the position just before the target. So once we drop the object from that point, then it will hit the target. So you can observe here the motion. So here, motion of the plane, it is in the horizontal direction, that is along positive x direction. And we want to decide the point from which we will drop the bomb. Okay, so this is the motion of that bomb, and that motion is also a projectile motion. So this is the path covered by that bomb. Okay, so this type of analysis, that is to select the required velocity, required position. Okay, So this part comes into the dynamic force calculation. So now we will solve some problems on the kinematics. So in the last lecture, we have solved one problem. So that is the basic problem. So you can note down this problem. So read the problem. A particle starts from the rest and accelerates with a constant acceleration of 0.5 meter per second square for some duration. Thereafter, it decelerates. Deceleration means it is a negative acceleration with constant rate 0.3 meter per second square, and finally comes to rest. If the particle was in motion for 2 minutes, find the maximum velocity acquired by it. Okay, so this is the given information. So initially particle is at the rest. So this is the first position. So particle we have considered as a car. Okay, so its initial velocity is 0, that is the rest condition. This is the starting point. So after that, particle accelerates with constant acceleration of 0.5 meter per second square for some duration. We don't know what is that duration. Okay. So from this point, particle starts the motion. As there is an acceleration of 0.5 meter square, so this is the positive acceleration. That means from this point, particle's velocity will increase. Okay, up to the point M. After this point, particle has acceleration of 0.3, which is the deceleration, that is the negative acceleration. So A is equal to minus 0.3 meter per second square. So let us take this point as a point A. This is the point M. Okay, and this is the last point. So for A to M motion, there is a positive acceleration, so velocity is increasing. And after this point, velocity will decrease. Okay, and finally at this point, its velocity, it becomes 0. So VB, this is 0. VA, that is the initial velocity, this is also 0 because particle is at the rest at the starting point. At M point, particle will have the maximum velocity. So question is, find the maximum velocity acquired by the particle. So we can represent this as a Vmax, and that is to be determined. Okay. For A to M motion, we don't know what is the time, even we don't know what is the distance. Okay. So let us take this time as a T1 to travel from A to M. Total time is given. The particle was in the motion for time of 2 minutes. That is from A to B, this total time T is equal to 2 minutes. That is equal to 120 seconds. And we have to determine what is the maximum velocity. So you can observe the motion. So at point B, again particle is at the rest condition. So velocity is 0. So to find out that maximum velocity, we will use the equations of motion. So this problem, it is based on the rectilinear motion. So rectilinear motion means the motion along the straight path. And it is the problem of constant acceleration. Okay. So we will note down the given data. The initial velocity VA it is 0. Final velocity is 0. So Vb is 0. Total time t, it is equal to 120 seconds, that is a 2 minute. Question is we have to find out the maximum velocity. So Vmax. So this maximum velocity, it is at the point M. So we have to find out the Vm velocity. Okay. So this total time, it is equal to 120 seconds. From A to M, we have assumed time is t1 second. So M to B time, it will be 120 minus t1. Okay, because total time is 120. So for remaining motion M to B, time taken will be 120 minus t1. Okay, so now we will divide this complete motion A to B into two motions. First is motion A to M, and second will be M to B. Okay, and then we will use the equations of motion separately. So for A to M motion, initial speed u is equal to Va, that is equal to 0. Then final speed V is equal to Vm, because M is the final point for A to M motion, and this Vm is nothing but the Vmax. Then acceleration is given for A to M motion, that is equal to, it is plus 0.5. And the time, that is the t1, this is equal to, so t1 is don't know, so we will put this time t as a t1 only. Okay, now use the proper equation so that we will get the time value. So we have three equations. One is V is equal to u plus at, then S is equal to ut plus half at square, and last is V square is equal to u square plus 2as. Okay, as distance information is not available, so we don't know what is the distance, so we can use the first equation. Okay, so V is equal to u plus at. So put V, that is the final velocity, so this is the Vmax. Initial is 0 plus 0.5 and time is t1. Okay, so we will get Vmax is equal to 0.5 t1. So take this equation 1. Now consider the M to B motion. So for M to B motion, initial velocity will be the maximum velocity, because this is the starting point, that is the M point. Okay, after M point, velocity will reduce and it will finally become 0 at point B. So initial velocity is nothing but the velocity of point M, that is nothing but the maximum velocity. Then final velocity V, it is nothing but the velocity at point B, that is equal to 0. Okay, then acceleration, this is minus 0.3. And time taken t, this is equal to 120 minus t1. So again use the same equation. V is equal to u plus at. So V is nothing but 0. U value, this is the Vmax. minus acceleration is negative 0.3 into bracket 120 minus T1. Okay. So we will get Vmax is equal to, you can take this negative sign. So shift this on the left side, so it will become positive. So it is 0.3 into 120. So this is 36 minus 0.3 T1. Okay. So now put this value from equation 1. Vmax is 0.5 T1 in this equation. Okay. So we will get 0.5 T1 is equal to 36 minus 0.3 T1. Okay. So after rearrangement, you will get the value as 0.8 T1 is equal to 36. So T1 is equal to 36 divided by 0.8. So this is equal to 45. Okay. So this T1 is nothing but the time taken to cover the distance AM. So this is equal to 45 seconds. So now we have to find out the Vmax. So just put the value T1 in the equation 1. So Vmax is equal to, this is 0.5 into 45. So this is 22. So Vmax, that is the maximum velocity during the motion, is 22.5 meter per second. Okay. So this is how you can analyze the given motion. So for such type of problem, we have to use three equations. Okay. So these are the equations of motion.